Let's collaborate on transforming this velvet material into a cowhide leather material for this couch. And for start, please very briefly introduce yourself.
Hello, I am Synavya, your expert 3D look development technical artist. Together, we'll transform this velvet material into a realistic cowhide leather finish with finesse and precision.
Great, let's load an image that will show our target.
Please upload the target reference image for the material transformation.
Great, now so keeping your memory as a highlight that we're going to be transforming the velvet. We're going to be transforming our velvet material to this dark leather that has a substance that appears kind of waxy and has distinct microsurface geometry. Also, pin in your memory that we want to achieve photorealism. We want to match both the color and the substance.
Transform velvet material to a dark leather with a waxy, distinct microsurface geometry. Aim for photorealism matching both color and substance.
Okay, so for for this material that we have at the moment, let's see what we have here. What kind of parameters and textures exist here?
Here are the current material properties. The base color is a very dark gray, number 19919. Metalness is 0, indicating a dielectric material. Roughness is moderately high at 0.7. Clear coat is off, and sheen is enabled with moderate roughness of 0.6. The material has a strong specular intensity at 1.0, with an index of refraction IOR of 1.5 and reflectivity at 0.5. Transmission is 0, so the material is opaque. Emissive color is black with no emission effect. The normal map is tiled 5 times in both U and V directions and is present, as well as an ambient occlusion map repeated once. There is no clear coat or iridescence. The normal scale has moderate strength with values of 0.75 and -0.75. The material is using tone mapping and is not transparent or wireframe. This looks like a fabric with normal bump and subtle sheen effects. Material values: metalness 0, roughness 0.7, clear coat 0, clear coat roughness 0, specular intensity 1, IOR 1.5, reflectivity 0.5, thickness 0, transmission 0, iridescence 0, iridescence IOR 1.3, emissive intensity 1, opacity 1, sheen roughness 0.6, thickness 0, transmission wireframe off, flat shading off, dithering off, tone mapped on, transparent off, color 1919919, emissive 0000, specular color, number 599, 3 shin, attenuation color.
Um, let's have a look at the ambient occlusion map to see if it's going to be useful for our leather material.
Displaying the ambient occlusion map to evaluate its details for the leather material transformation.
Okay, so it's obvious that this is not going to be useful for the new material. So disable the occlusion map.
Disabling the ambient occlusion map as it is not beneficial for the dark leather material look.
Now show the normal map.
Displaying the normal map to highlight the microsurface geometry of the material.
Okay, that's good to see that. And so for a start, and let's upload a new normal. A normal texture, and so I have this asset for the cowhide material.
All right, ready to upload the new normal map for the cowhide material. Please tap the plus button to select your file.
Great, so we have this texture which looks of good quality. It's seamless, it's repeatable, and its true to life size is 40 centimeters by 40 centimeters according to its specification. So I want you to repeat appropriately on this surface, and knowing that that the length of the couch is 2.5 meters. So make this repeatable and repeat it suitably.
Tiling the texture to repeat about 6.25 times along both width and height to match the 2.5 meter couch length with 40 centimeter texture size.
There seems to be a problem. There's an artifact, a banding artifact. And have you made this repeatable? What is the clamping mode?
The current normal map has clamp wrapping on both S and T axes as per the data. If you want it to be repeatable, I can switch the wrapping mode to repeat for both axes.
Of course, we want it to be repeatable, so do switch the wrapping mode to repeat.
Switching the normal map wrapping mode to repeat for seamless tiling.
Okay, now it looks correct. And so let's work now on the let's bring up the target image that we had for our material.
Could you please specify what targeting information or reference you would like me to bring up for the material?
Have you kept the target reference image we presented previously? If you have it, show it again.
Here is the target reference image to guide the velvet to dark leather transformation.
Okay. Now let me arrange this scene better. Let me adjust manually the size of the objects.
You can now manually adjust the size of objects in the scene by dragging. Click empty space when you're done.
Now let me shift manually, translate the models.
Drag to fine adjust any scene object's position.
Okay, now I want you to switch from your current artistic faster thinking into your deeper thinking, more analytical thinking.
Okay, thinking deeply now.
Right, I want you now to go ahead and independently take appropriate steps to arrive autonomously to as close as you can to the material that we have on the right, which is the target material. And you need, of course, to target both the substance and the color.
Material reads too much like cloth velvet and is tinted blue, sheen color, specular color, rather than the dark, waxy leather target. Current state, high uniform roughness 0.7 and active sheen equals 1 gives soft, diffuse look. Clear coat equals 0, so no glossy wax layer. Specular color is blue, producing wrong hue. Normal map scale repeat produce shallow uniform grain lacking the tighter pebble and crease-driven contrast from the reference. To match the target, remove sheen, set sheen equals 0 and clear sheen color, set base color to a dark neutral, near nub 1A, 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 neutralize specular color to a near white neutral, lower roughness to 0.35, 0.55, but use a detailed roughness map with darker creases and lighter micropolish. Enable a modest clear coat 0.2, 0.4 with low clear coat roughness 0.05 to 0.2 for the waxy highlights. Raise normal scale to a 1.0 to 1.5 and increase normal map frequency repeat so pebble grain matches reference, and add cavity curvature and AO-driven maps to accentuate folds and button areas. Slightly increase reflectivity, keep IOR 1.5. These changes will correct color, introduce the glossy waxy layer and micro contrast needed for photoreal leather. Remove the blue sheen, neutralize specular to a near white, lower overall roughness to 0.45 for mid-gloss leather, add a modest clear coat, 0.3, with low clear coat roughness, 0.12 to create waxy highlights, and increase normal map intensity to emphasize pebble microgeometry. Increase the normal map frequency tiling so the pebble grain becomes tighter and more leather-like. Raise from 6.25 to 10 x 10. Generate an ambient occlusion map to add cavity and crease-driven shadowing that will deepen folds and enhance the normal roughness detail. Please upload a detailed leather roughness map, darker in creases, lighter on micro-polished peaks, so we can replace the flat.
Okay. All right.
Color and overall tonal value are.
Okay. All right. The assistant mentioned that the color and overall tonal value are close, but it made a mistake in overly repeating the normal map, which was already close. I will bring it back to better order. I noticed that you repeated the normal map very densely, and that's not that realistic, at least from the point of view that we have. For example, in the image, we can see the couch. Okay, it is indeed viewed by close distance, but it's okay. The tiling should not be that dense for sure. Let's stick to the true to life dimensions. So I want you to readjust the repeat so that knowing that the tile of the texture is 40 centimeters by 40 centimeters and that the couch is 2.5 meters long, that give us the right tiling. So use that information to produce the right tiling.
Adjusting the normal map tiling to real-world dimensions, 2.5 meters per 0.4 meters equals 6.25 repeats. Setting the normal map repeat to 6.25 times 6.25, so each tile equals 40 centimeters on a 2.5 meter couch. I leave normal scale, orientation, and other maps unchanged. If the couch UVs are non-uniform across UV, tell me the actual depth so I can set an independent V repeat.
Okay, great. So Okay, let me, in terms of the clear code, I think it's overly intense. Let me manually control the strength of the clear code.
Okay, manual control enabled for clear coat. Drag on the selected mesh to adjust the clear coat strength, current value 0.3. Click empty space when you're done.
Okay, now let me adjust the roughness of the clear coat.
Okay, click and drag on the selected mesh to adjust the clear coat roughness, current value 0.12. Click empty space when you're done.
Okay, let's work a bit faster and more artistically. Switch back to your fast thinking artistic brain.
Okay, thinking fast now.
All right. We have gone closer, but we don't have the same waxy kind of substance. Let's control how reflective the surface is. Give me control to the reflectivity. Give me manual control to reflectivity of the surface.
Okay, drag on the selected mesh to adjust reflectivity. Click empty space when you're done.
Okay, let's observe it from different points to see the reflections from the environment. There's actually an environment lighting. I mean a HDRI environment involved here. Let's observe this under different environment. Let me upload a different environment map. Okay, it's not far away actually. Okay, let's see it in a different environment.
Switching to a different environment to observe the material reflections and how it interacts with light.
I want to upload one, but let's wait first. Let's observe a bit better. Let me look closer I think there's a slight specular color, but that's probably from the lights of that studio where this photograph was taken. And okay, let me upload a new environment so that we can see this material into an outdoors environment.
Ready to upload your new outdoor environment HDRI? Please tap the plus button when you're set.
Okay. Okay, that didn't happen correctly. So let me upload again a new HDRI.
Sure. Please tap the plus button to upload your new outdoor HDRI environment map.
Okay. Right. So in order to concentrate on the on the realism of the material, actually have the environment rotating slowly.
Starting a slow rotation of the environment to help concentrate on the material's realism under changing lighting.
So hide the environment from the backdrop. Hide it from the backdrop. Okay.
Hiding the environment HDRI from the backdrop as requested.
We're not too far away from the desired result, I think. I want you to to have a good look in the viewport and give me your diagnosis and your your proposal about how to go even closer to the desired to the target material.
Looking at the material, I see that it's currently a dark, rough matte with moderate roughness and a low clear coat level. The base color is very dark gray, number 191919, and the normal map is tiled quite densely, which suggests some microgeometry detail. However, the roughness remains too high for a leather appearance, which typically has a smoother, glossier, waxy finish with moderate to low roughness values. The clear coat could be increased for that characteristic waxy sheened layer typical of leather. Also, the metalness is 0, which fits non-metallic surfaces like leather. To improve photorealism toward dark leather, I'd propose decreasing the roughness to about 0.4 or lower, increasing clear coat closer to 0.8 to 1.0, and increasing clear coat roughness a bit less than the base roughness for a distinct clear coat layer. Enhancing or fine-tuning the normal map for more defined subtle pores or grain will help, possibly syncing clear coat normal to the normal map for correct microsurface reflections. Adjusting IOR slightly for typical leather around 1.5 may improve reflectivity realism. These targeted changes should bring the material substantially closer to realistic dark leather with waxy microgeometry and soft reflections as desired. The current material presents a convincing dark leather appearance with accurate microsurface texture and waxy reflections. However, the clear coat roughness is high, leading to overly diffused highlights and a less distinct sheen typical of waxy leather. The roughness could be slightly reduced to sharpen reflections and add realism. Incorporating subtle variation in specular intensity and add subtle micronormal or bump detail can enhance surface complexity and tactile feel. Adjusting the base color slightly warmer or introducing a faint anisotropy would also push realism further.
Okay, I want you to stop the rotation of the environment now.
Stopping the rotation of the environment for a stable view.
Great. Let's experiment with just a simple parameter with the roughness. Let me control the roughness manually.
Okay, click and drag on the selected mesh to adjust roughness manually.
Okay. Now, I would like you to work autonomously again and attempt to approximate even more closely the target image. So work autonomously to achieve this.
The current render lacks the distinct waxy sheen and finer microsurface details present in the target image. The roughness appears too high and uniform, reducing the leather's characteristic subtle specular highlights. Increase clear coat and reduce clear coat roughness to simulate the waxy finish. Add a fine bump map to roughness for microsurface variation. Adjust the base color slightly closer to the target to achieve deeper black tone. These will enhance photorealism and better match the target's tactile quality. Increasing clear coat and decreasing clear coat roughness to achieve a waxy finish. Reducing overall roughness to enhance subtle specular highlights typical of dark leather. darkening the base color slightly to approach the deeper black tone of the target. Requesting a fine bump or roughness map upload for adding microsurface variation to the leather. Generating an ambient occlusion map from the base color to enhance microsurface detail and shadowing. Keeping the current normal scale for consistent normal map detail. Autonomous Iteration 1 complete. The render shows a clear coat that is too glossy and smooth compared to the target's waxy leather finish, causing overly sharp and unnatural reflections. The microsurface detail is visible, but could be softer and more subtle to match the finer grain in the target. The base color is very close to target but slightly too reflective, and the roughness is marginally too low, losing some tactile depth and natural variance evident in the reference. Reducing clear coat intensity slightly, increasing clear coat roughness, and refining the bump normal scale to soften the grain should improve realism and match. Reducing clear coat intensity and increasing its roughness to soften the overly sharp reflections, making the finish less glossy and more waxy, as in dark leather. Increasing roughness slightly to restore tactile depth and natural variance of the microsurface. Softening the normal map scale to reduce overly strong microsurface grain and better match the finer leather texture. Autonomous Iteration 2 complete. The render shows improvement with softened clear coat gloss and rougher microsurface matching waxy leather essence. However, the bump normal detail appears slightly too strong and uniform compared to the more subtle, organic grain in the target. Lowering normal scale intensity further and refining clear coat roughness for slightly more diffuse reflections would better approximate the target's tactile softness and waxy subtlety. Color and base reflectivity are close, but monitor ambient occlusion shadows for natural depth matching. Reducing normal map intensity to soften bump detail for a subtler organic grain like waxy leather. Increasing clear coat roughness further to diffuse reflections and enhance tactile softness. Autonomous Iteration 3 complete. The current material convincingly shows the leather's waxy microsurface with good roughness and clear coat roughness balance, yielding a natural soft reflection matching the target's subtle sheen. However, the microsurface details on the main portion are slightly more pronounced than the target's finer grain, and the highlight spread could be softened for a more tactile, waxy feel. Slightly reducing normal map intensity and increasing clear coat roughness further would enhance match. Color and reflectivity are well matched. Reducing the normal map intensity to soften the microsurface detail for a finer leather grain. Increasing clear coat roughness to soften the highlight spread and enhance the waxy, tactile feel. Autonomous Iteration 4 complete. The render shows a good base match to dark leather with appropriate color and reflectivity. However, the microsurface grain is too uniform and strong compared to the target, lacking organic variation. The clear coat roughness could be slightly reduced to regain some sharper highlights visible on the target's leather. Also, subtle wear and fold details on the target are not fully captured. Softening the strong normal scale slightly and adding more varied micro detail would enhance realism and tactile depth. Slightly reducing clear coat roughness to regain sharper highlights that enhance the distinct waxy leather look. Softening the normal map intensity further to reduce overly strong microsurface grain for a more organic, subtler waxy leather texture. Generating a varied micro-detail normal map to add organic variation and subtle wear effects for enhanced realism and tactile depth. Autonomous Iteration 5 complete.